Hello, this is Mr. Collier, and today we're doing some kinematics with calculus. Okay, so in the first question, a particle is moving in a straight line such the acceleration is a after t seconds is given by this. Initially, the particle is at rest at s equals 2, a distance of 2 away from the origin. Find v as a function of t. So we start with acceleration. To find velocity, we need to find the integral of acceleration. Okay, so we got displacement, velocity, acceleration. If you want to go this way, you differentiate. If you want to go this way, you integrate. Okay, so the velocity as a function of time equals the integral of 4t minus 8, which equals 2t squared minus 8t plus a constant. So then we can go back and look at the information in the question. It starts at rest, initially at rest, so when t equals 0, the velocity is 0, so basically we can plug that information in and we get c equals 0. So you don't really need the c in this situation. The velocity is simply that. Okay, part B, s as a function of t, so we've got to integrate again. So s of t, and s is often what is used for displacement. It's the integral of 2t squared minus 8t dt. So that is t cubed, so that's 2/3 t cubed minus 4t squared plus another constant. I guess we can call it c, or I'll call it d, not to confuse it with that one. And it's originally at rest at s equals 2, so that means we can plug in 2 for the s and plug in zeros, and we get d equals 2. So this constant is 2. Okay, so that's the displacement is 2/3 t cubed minus 4t squared plus 2. When is the particle stationary again? So that's when the velocity equals 0. So we can plug that into the velocity equation. 0 equals 2t squared minus 8t. We can factorize that. That's 2t times t minus 4. So initially, this one gives you t equals 0, which is the initial one. So at t equals 4 seconds, that is when it is stationary again. Okay, next one, show that the object moving with a velocity, this velocity here, stops when t equals 3. So then we can just plug in t equals 3. So velocity equals 3 squared minus 3 minus 6, which is 9 minus 9, which equals 0. Therefore, it stops at t equals 3. And part B, find the total distance traveled. Now you have to be careful because, well, first of all, to get the total distance traveled, we need to find the integral. But we have to be careful because some parts could be underneath the graph and underneath the x-axis, some could be above, and they would just cancel each other out. So let's see if we can do this non-calculator. Okay, so this is t minus 3 and this is t plus 2, so I factorize it. I can see the, so we have t equals negative 2 and 3, and it's going to be upward facing. The y-intercept is negative 6. Maybe that's irrelevant. So I think the vertex is going to be down there like that. Okay, so first 5 seconds goes from 0 to here. Let's say 5 is over here. So you can see some parts are above the x-axis, some are below. If we use a calculator, you can simply do 0 to 5 times the absolute value of the function. Okay, because I'll take all the negative regions and put it up here, and then they'll all become positive and just add up the total area. But if you're doing this manually, you want to do this integral from 0 to 3, the absolute value of that, which is, what's the function? T squared minus t minus 6. So when you do that, That's an absolute value sign, plus the integral from 3 to 5 of t squared minus t minus 6. Okay, so if we do that, actually I'm just going to let you try that yourself. I'm going to use the calculator. If you type this into the calculator, you get, actually let's just try that. Okay, so we use this button right here. And the integral function's right there. So we go 0 to 5. Okay, and then in here we need absolute value. I think you can click this button again. And there's absolute value. Then inside we've got to type in x squared. So x squared minus x minus 6. And there we go. So just press enter. Get that. Let's see if we can change it to a fraction. It's 157 over 6 if you want a fraction. Okay, 157 over 6. Okay, next we're going to do this question where we're given the velocity and the time interval. When is the particle at rest? So you're going to solve 0 equals sine 2t. So when is the velocity equal to 0? We'll need to change the range to 2t, so we can multiply by 2. So we can go all the way up to 4. Sine is 0 at 0 degrees and at pi degrees, or pi radians, I mean. Okay, so our answers are 2t equals 0 or pi, so t equals 0 or pi over 2. So, and if you want a decimal, you can type it into your calculator and get whatever pi over 2 is. When is the particle moving to the right? So moving to the right is in the positive direction. Moving to the left is negative. So we're looking when the velocity is positive. So this is, well, we know what sine looks like. Sine looks like this. So this is pi over 2, or yeah, pi over 2, or sine 2t. And so after that point, it's going to be negative and moving to the left. So between 0 and pi over 2, it's moving to the right. What is the particle's position after 2 seconds? So you need to find a function for the displacement. Okay, so we need to integrate this. So if you integrate sine 2t, you get cosine or negative cosine 2t over 2. Okay, so that's that function. Plus c, of course. So remember, the constants actually matter for kinematics. So let's go back to the original question. It starts at the origin. So the original position is 0. So actually plug in, you don't get 0 for that. You got to plug in 0. Or, yeah, okay, we'll write that like that. S0 equals, so he starts off at the origin. That equals negative cosine of 0 over 2 plus c. And 0, cosine 0 is actually 1. So you're going to get negative half plus c. So 0 equals negative half plus c. So c equals half. Okay, so S of 2 equals negative half cosine 2 times 2 plus half. Okay, you type that in your calculator, make sure you're in radian mode. Get 0.173. Okay, so that's the position after 2 seconds. Total distance traveled is the integral from over the entire motion of the particle, 0 to 2. Now some of this stuff is above the x-axis, some of it's below, so you can do absolute value, and actually you could always do absolute value on your calculator just to be sure. So you can just calculate this integral. Make sure you're in radian mode, and you get 1.17.